Hello, everybody. Welcome to the Kotlin conference at the Lazada office. Um, Thank you. So today I will talk about the Jetpack Compose, and that especially for the side effect with the coroutine. So wait a second. Okay, it's working now. A very quick introduction about me. My name is Fat. I'm currently working at Lazada. I'm a dad of one, and some of my hobbies. I love reading mangas. The current one that I'm reading is Blackjack. I also love swimming. I'm currently practicing for the freestyle swimming with a dolphin kick. And finally, I love language that I currently learning. I try, but it's not working efficiently. I try to learn Spanish and French at the same time, mostly on the Duolingo, just for information. So, what is the Jetpack Compose? So, it's 2023, right? So, and Jetpack Compose, one of the latest, iteration from Android that joined the race. I mean, the very competitive and also at the same time healthy competition that focus on building the declarative UI framework that can help you to, build, simplify your workflow to build a beautiful Android app. So just a few lines of code here. This is a very first Hello World composable. With just few lines, you can create your own composable, and it's just working. You can see the Hello World titles here. I can also create a simple menu items here with a composable. And you can see we can have the prefix icon. We have the title and the detail, the navigation icon that the user can click on to get detail of the menu. With the ability to reusable, I can add them into the menu section. Like we can have the very cool menu section here with 4 items. And also you can use the animation API, which is a unified animation API. One of the tasks that I want to touch while working in Android is the animation, but right now you have the API that can help you to create the animation that collapsing and expanding with just few lines of code. You can handle for the rotation or the visibilities of the content right here. Okay, so first thing first, life cycle. So some of you might be questioning that why I put this line on the very first line of detail of the composable. So composable life cycle is something that very important in the composable. When you have a clear definition, when you are clear about the life cycle, you have more sense on all the definition of the composable. There is a very high, correlation of the life cycle, the state, and also, the side effect. So to talk about the life cycle here, there will be 3 phases. The first one will be the composition, where it can describe how the UI look like, right? So this is the 3 structure that we have in the previous example, the menu 1, and then we commit those change to the second phase, layout, where you can measure and you can place them onto the UI. And finally, we can draw on the device, which is a thing that user actually see. So definitely there's something like, running in the order here. The minor change of the composable, of the composition can impact directly to this what user actually see on the device. This is the cascade butterfly effect, whatever you want to say. But any change, any minor change of the composition will impact, will try to make the UI to be changed. There is only 2 places in the composable that actually trigger the change here. The first one will be the initial composition. When you are the first time you enter the composable, they will take your default parameters and try to render the UI based on default values. And for any change during the process of the smart compose, there's something under the hood here that called smart compose, which is the process of identify any change, any minor change in the small portion of your layout, they will try to check that and then reflect that one onto the UI. So this is the process of the recomposition. So during the life cycle of the composable, the recomposition will come many times. And the only way that we can trigger the change here is by using the state. So back to the few years ago when I first touched to the React. So I asked my brother, he's a software engineer too. I asked my brother to do like, how do you get the value? How do you get the input value for the users? When you example that we have a text view, how do you get that value when they click on the submit button? So he says something like, well, you can just create a state variable, and whenever the user change the input value, right, we try to observe that change and try to get the latest snapshot of that value into the variable. So that is something weird for me because at that time, I'm mostly working on the imperative way. When user click on the submit, right, we just getting the text view, getting the view, and then to just dot text, and then you can get the full detail. What is the user actually typing on the screen, right? So when I get into detail of that thing, there is something that actually shaped my mind of the new concept, the new establishing concept in the React, which is the DOM view. When right now you are not working with the view anymore, the view is just basically the place that you render the data. For any kind of the change of the state, the view will be reflected, and the only job here in the view is to respond interaction from the users. Like they click on the view, they try to choose something new with the spinner, and then everything you are working right now, you're working with the state directly. You don't touch to the view. Okay, so I have a very iconic example here. So this is a very simple composable with the text view, and you can see it's not working, right? Then this is the local variable. The reason why it's not working because, first of all, the local variable doesn't persist between the recomposition. Just go in this way, right? When you get into the composable, we try to reset the text local variable here to be empty. And then whenever let's notice here, we have the text view with a value in the text, and also we have a callback which is on value change. Whenever the value change, we try to change the text with the it is reference or the callback function. So whenever we get into the composable, the text try to be reset again, which call the composable to not getting any updated value. And the second thing is that we don't have any way to trigger the the recomposition here, right? Whenever the text change, it's going to reset again and again and again. This kind of loop. So how do we fix that? By just adding, the remember keyword here, we let the composable to know that they need to store something, they need to remember something. And the thing is here is state, which is a mutable state of the state of the text with the initial value is empty, and it's mutable, which means we can change the value of the state later. So what we actually do here, the first one, we define the remember here to make the state retain between the rendering between the recomposition, right? And the second thing that we actually do is we have a way to let the composable know, okay, this is the thing that we want to trigger the change, right? So whenever they typing anything, when they come in the composable, they know the text here is no longer a local variable. This is the state, right? And the state, they have the previous value and they have the current value. And whenever they change something, the text will be reflected as well, which also trigger the view to be updated here. So there is a tool in the Android Studio, which is layout inspector. So as you can see on the left, under the text view, there is the internal text view state, which is the internal state of the text view. Whenever we typing, I hope it's not too small for you, but whenever we typing something on the right on the screen, the counting is increasing. The counting is increasing, right? This is the internal state of text view. It's not a state that we just define. So what is the lesson here? So let's say we have the composition, the recomposition, or you can say the re-rendering, revoking the UI, or anything that you want to say. The process is fully controlled by the composable, meaning that we don't know when the recomposition happening, right? We don't know when. The only thing that we can do is just when it's happening, like for every single recomposition happening, what should we do? How should we react to that one, right? How should we react to that one? That is the thing that we should do. And none of the single recomposition should surprise us. That is a first one of the, that is a first rule, right? And okay, so how can we react to the composable? For every recomposition here, for every revoking the UI here, by using the side effect. So this is remind me of the connection of, you know, the life, every decision that you're making today is impact to your futures, your tomorrow, more or less, but it will, right? So, but it's not working like you are expecting. Sometimes it has some side effect that you know, it's unpredictable. The only thing that we can do is how we react to that situation. That is the thing that we can do. So the side effect is very similar here. So by the definition of Android, the things that are not inside the scope of the composable, meaning the side effect. For example, in this one, we have a row. We have a list of items which can be changed anytime, right? We have a my list here. And we have the local variables. So whenever something change, they want to counting how many items inside that list. It could be right, it could be wrong, but it's working in unpredictable manner because let's say if during the renderings, the list has been changed, and then the items here is no longer working as you expected because that can be reset, right? So it's not working at the way you are expecting. So this is something that they call the side effect. So there is API for them to handle those kind of side effect here. So some of the side effect that you can imagine is like getting the latest information of the product, right? Getting the latest information of the card, the current buying card, or it's just a toast message that you want to use to see it, or just a pop-up for the great version. That is something that happening during the life cycle of the app that we don't expect it, but it happened, right? Somehow we need to fully control of that one. So the very first side effect capabilities of handle side effect here is the launch effect, which is a way that we can run the suspend function in the scope of the composable. I love Java and Kotlin. One of the things that I love to use them, especially on the Jetpack IDE, or any kind of IDE that you want to say, that you want to use, is you can get the detail of any function, anything, like on Android or like on Kotlin or anything, that you can go into there and get the detail of how they actually implement it, right? So this is, so we will work in this way. So for every side effect that we mentioned here, I will try to put how it's actually implemented under the hood, right? So we can better view of how they are designed from the developer's perspective. So the first I want to mention is that we have the annotation of non-restartable composable here. So it will imply that whenever they go into the recomposition process, this is the composable, this composable will not be checking, identify if anything changed, right? They will not generate for any kind of UI. They will not be get into the loop of checking for the recomposition will not generate for any kind of UI. With the input here, we have the keys. The key here is how many keys that you want to input here is fine. It's the parameters. And for any keys of this thing to be changed, there will be the function that we put in here. This is the lambda function, right? For any time, for any keys inside the list of key change, we will try to launch the suspend function that we define already in the block above. This is the example for the launch effect. I have 3 text field and the login button. So there, I hope it's not too small for you. Yeah, I think it's good. So we try to observe the change of the email, the username, and the password, which is the state here. And for every single change of those kind of things, we will try to run the function, which is a validate contents. That will take us 1 second. And then we will try to trigger the new state, the enable state for the button, right? So we try to check if it's not empty. So this is the detailed login that I'm receiving from the IDE. So if you notice that it's working properly, right? But more important thing, you see on the log here, I will say it out loud if you don't see it. So the timer will be started, and later on it cancel, and later on it started and cancel. It cancel many times here. It's cancel many times here. The reason why, because in the detail under the implementation, there is an observer, right? We know that there is some kind of hook, hook under the hood that we can keep observing what had been changed in the life cycle of the composable. And there's 3 important functions here. We have on remembers, on forgotten, and on abandoned. Abandoned means that whenever the composable leaves the composition, meaning it's no longer in the UI tree, right? So abandoned will be called. But whenever it's forgot with the previous value and update with the new values here, the suspend function will be immediately cancelled, and then they will try to run the new one. So keep in mind that with the launch effect, the previous function will be cancelled and the new one will be started right away. Any change in the keys of the launch effect. Okay, so my question is, then how we can, we have a valid use case here, like when you enter the composable, you want the animation to be running only for the first time only, right? Or you want to get the API to be called to get the latest, remote config from the server, and then you want that to be called one time only when it enters the composition. So what is the valid use case for that? So we will try to use the key parameter again here by using any kind of constant value, like the unit or like the phone, choose anything that you want. As long as that is the constant value, that's fine. The reason why it's working, because whenever a recomposition happening, it go into the launch effect, and the smart compose process happening, it try to comparing the previous value of the key and the current value of the key, and both of them are identical, meaning that the launch effect is still working, is still running, but the smart compose identify both keys is the same. So it not trigger the suspend function inside the launch effect. So that you can see on the so the result of this example is that the first time they enter the composable, there will be a text ABC on the text field. Okay, the second is the remembers coroutine scope. So the launch effect working properly inside the composable scope, which is under the composable, you have the scope of that and working, but it's not always composable scope. Like we also have the row scope, the column scope, and many other scopes that just running the function like the navigation or animation. It's not always like you can imagine it's not always in the context of the composable. It can be the context of other function. So in the detailed implementation, there is something that they call the composition scope coroutine scope cancel here. The name is too long, so I just get into the detail here. The only thing that different is the on remember here is no longer cancel the previous one. And with the help from the coroutine scope, we can cancel all the job inside that scope like instantly. So let's say we have an example here. We have a timer, and whenever the timer is running, we will have the log that timer started. And then after 2 seconds, we will say something like the timer ended. For any case that the timer is no longer working, and then we will have the exception to be saying like the timer is canceled. So it's quite obvious that whenever we click on the button here, the timer will be started. As long as we click it, it will be started, and it wait, and it will be ended, right? So it started, wait a bit, ended. Even I change orientation, I mean the auto rotate function on the Android phone. So whenever you rotate something on Android, the view will be recreated. So in this case, the composable or the view will be destroyed and recreated, but the job is still, you can see that we have the only way that we can cancel this job is by removing that composable out of the scope of the entire screen. So as you can see, the timer is canceled here when I rotate the phone. Otherwise, it will be calling, waiting, and running. Even for any kind of state that changing, is still running. Okay, one more side effect from Android. We have the remember updated state here. So this is quite simple. You would try to create a new state, and then you observe for the latest snapshot of the provided state in the parameters. Okay, this is the example. I will try to expand the example. So you have the current text, the state, which is the state with the default value is empty. Whenever you clicking on the button, I want to have the text to have a new character to be shown on the button text, right? So, but if you notice, when I click on the button, it's not working because here in the remember updated state, we have a launch effect. And we mentioned before, the unit here means that we only run this function one time when it recomposes, right? So the timer end here 5 seconds, but the content of the button is not updated. Why? The reason why? Because when the launch effect is running, it already take the parameter here, which is the text on the parameters on the function, right? And that will be saved at the time. At that time, it's like you are going to the office in the morning, and then the boss assign you for one requirement, and then at the end of the day, and they say, hey, I have limited a requirement for you, and you say, no, I only do the first ticket that you assign to me. That is the thing that I do today. So how do we fix that? By saying that here, the button text here, to remember always remembers the updated state here. We're saying that the composable will try to get the latest snapshot of that state. Even you are running in the launch effect unit here, it's still getting the latest value of the state of the text here. So whenever I click on the button, the new character will be at the end of the contents of the button. So this is the official example from the Google. So the intention is quite simple. They want to have the landing screen, and it will be delayed after 5 seconds or something like that, right? But after 5 seconds, if the callbacks are on timeout change, they want to get that kind of callback to be running, the new one. Like at the first time, they want on timeout to be running a different function. But at the end of the delay timeout, they want to have something new to be run. That's fine, because we already remember the updated state of the on timeout here. The next one is disposable effect. There should be a way that we can clean things up, right? Like in this case, this is the behavior when a recomposition. So they basically have the on dispose here, which is internal way that we can store the state, and then whenever they forgot, they will try to dispose that. Like in the case of the camera review here, so we have the camera to be running on a composable. So whenever we go into the screen, we want that camera to be shown on the screen, and then if it's no longer used, we just clean that out, and then dispose function will be called. This is the side effect that we want to have something from the compose state to non-compose state. So this is one example. Simple. Like every time the recomposition happening, you try to run this function. Nothing special with this. So for example, if you notice, we have the return value here. This is the remote config, right? And the remote config, whenever something changed, like the user, the region, or the app key that we change here, and the recomposition happening, we try to run that function. We try to update it with the new value, like the set value here, and then we return that kind of composable state to the non-composable state, right? Derived state of. So the derived in English, I mean, origin or the root, right? So for the guys that want to optimize how the state, you want to manipulate the state, you want to optimize that thing, and there will be some operator for you. This is the derived state of. So in this case, we have a text that with the default values is empty. So my intention is whenever the text and that had the size more than 10, and then we try to enable the button. So we define derived state of here. It's like this thing until change. So we will try to compare all those kind of logic until it getting the size longer than 10, and then we'll try to enable the button. In contrast, whenever the size is lower than 10, and we'll try to disable it again until it has something change in terms of the state. So some of the remarks here. So not only we want to use launch effect, right? Don't overuse that. The first thing, you don't need to side effect to transform the data for the rendering. This is the key term from the Google. So they say something like the effect will be running right after the recomposition, meaning you have entered the recomposition. They will try to check something to make sure that the key is identical, and then the side effect will be running. So let's say if we have a simple example here. We have the full name state, which is by concatenate the first name and the last name. Whenever the first name or last name change, we want to update that, but it's not necessarily needed because, when at the first time, we have everything to be empty, and then the recomposition happening, right? And then they will try to check for any change in the first name and last name, and it will run the effect right after the recomposition. And then, in this case, the full name had been changed, and full name is a state, and it will be triggered a recomposition again, which means, this could be perfectly working fine, but it's not necessary. We can just put inside, we could just put inside, the text here by the very simple logics. No need to have a launch effect here. And you don't need to use the side effect to replace the event handler. For example, we have the two buttons here, the add card and the checkout. And whenever you click on any kind of this button, we will try to record the ID of that one. So in the launch effect, for the button ID, whenever it changes, we will try to have the handler for that. But it's not necessary because let's imagine for the case of the AutoCAD, it's not simple in this way. You have to somehow record the current index of the product that you want to buy. Let's say if you're already in the cart, you want to increase the value, the size, the numbers of that thing in the cart. So just put it inside the event handler, the callback, because it's designed for you to know exactly when the user click on the button and have all the detail on the context of that thing. Okay, this is quite obvious, right? So when we define something like launch effect true, meaning that the recomposition happening is like there will be some valid use case for that, but make sure you are thinking about that twice before you are using that. What if we want to manually handle for the job? You can define multiple jobs here. You can also working in a way of the parallelly, but because it's not fully aware of how the composable is working in the life cycle of that, so make sure you know what you are doing. Whenever you want to cancel that, make sure you have the exception handler for that one. If you want to get it to be running, like if the state change, the composition happening, and you want to keep it running, and you don't have to handle that one, but make sure that you are fully understand and aware of those things to be changed. Okay, this is one of my latest iteration from Jetpack, but this is fully built in the Jetpack. You can find the titles, the name of the projects here. So you can go there and grab something that you want to learn, especially for the custom layout and animation, and also some of the credit that I use in the slide. Thank you.
All right. Yeah. Thanks, Paz, for the very interesting sharing.